Exactly. So we are working on an implementation of a generic dialogue system that is so far abstract argumentation based. And let me first motivate the work. So in general, we know that dialogues and formal argumentation approaches are intertwined. And there also seems to be relatively little work on generic software components for automating argumentation-based dialogues, or for just supporting them, even if they're not fully automated. And this is also something that Simon Parsons hinted at during his presentation during the summer school on argumentation. There are some libraries that focus on strategic aspects, but of course, dialogues are not necessarily always strategic. And I would even say from a practical perspective, it might be easier to disregard strategic use cases for the beginning, because, for example, game theoretical implications are quite hard to tackle. So what we did is we started to design and implement generic abstractions for abstract argumentation-based dialogues. And we start by focusing on our own ongoing theoretical work. Of course, this is a bit biased, but it also makes sense, of course, for us to implement our work. And this also means that there are a lot of implications, theoretical implications in the current implementation. And I try to give like a high level intuition on both the necessary theoretical aspects and the engineering aspects without going into detail at all. So I try to avoid any type of, let's say, formal stuff on my slides. So our focus. We consider an argument dialogue as a sequence of typically expanding argumentation frameworks. So we start with an argumentation framework, and then we add new arguments or new attack relations to it. And what we want to do is we want to enforce some consistency properties with regards to how we resolve this sequence or different argumentation frameworks in the sequence. To maintain consistency, and we can manage some context to further relax consistency and expansion properties. So consistency properties are typically relaxed forms of monotony. I will briefly explain them in a minute. And sometimes makes sense to just switch the context of a dialogue, and then you essentially have no constraints with regards to consistency. And we also provide some, let's say, some simple engineering interfaces like JSON serialization support. So if we look at the architecture of our reasoner, we have as its core essentially Tweety that does a lot of the heavy lifting. And then we implement abstractions for argumentation framework sequences and argumentation framework context, and the support of enforcing certain types of expansions and enforcing certain types of consistency properties. On top of this, we have a serialization layer, and then you would have the use case specific business logic layer and application layer. So what we do is essentially we take an argumentation framework, we pick an extension, we add new stuff to the argumentation framework, and we again pick an extension of this argumentation framework and so on. And to enforce consistency, there are two different approaches, or at least we cover two different approaches. The first one is reference independence. I talked about this in the morning. Perhaps some of you were there during the doctoral student session. This essentially means that if you just look at the input into an argumentation framework and the output, and if you would derive the decision maker's preferences from this, these preferences should be consistent as you go ahead and expand your argumentation framework and pick new extensions. And the other approach is based on cautious monotony or restricted monotony, which is a fairly old, fairly well established property for non-monotonic reasoning systems. And there we say the extension we pick should be a superset of the previous extension we have picked, if no attack relations between the previous extension and the newly added arguments exist. So if we look at how this can be applied, and here I again just give a very basic intuition. Let's say we have an activity recommender system that suggests us some activity to manage our lives, you know, to be, let's say, more aligned with what we actually want, and not only distracted by whatever we, you know, get into our mailbox and whatever. So the system now, let's say the user now has already observed two activities, meditation and social lunch, and the system encourages the user to go out in the evening. And perhaps there are potentially different activities that the system can suggest. For example, a pub and concert, relax, and because it only wants to suggest one, there are mutual conflicts between these arguments. And to essentially force a recommendation, we automatically put an annihilator argument that attacks two of the suggested activities, which then causes the system to give this concert and pub recommendation. But the user can essentially argue against it. So the user can say, okay, I actually don't want to do this. And the user could also actually argue context dependent against it, and could say, okay, I don't want to do it because it's a weekday now. And then it would be up to the system to come up with a next recommendation. So the user has now added another argument, and the system would then say, okay, they are now, so this argument actually completely deletes the annihilator arguments that the system has essentially forced upon the argumentation framework. And then there would be two reasonable recommendations left. And then the system would essentially continue down this road by placing, for example, another annihilator until the user has accepted an activity. For example, here this activity got to work out. If the user confirms it, then we would be done with this dialogue. And if the dialogue continues over time, then the system would make suggestions that are consistent with the previous recommendations. What we want to do in the future to further improve this idea and to further improve the generic abstractions we provide, we want to develop additional perspectives on context support. So most of the work has theoretical underpinning that is relatively mature, but we still need to publish it. But the context support still needs a better theoretical underpinning. We could integrate with traditional recommender system approaches, either completely machine learning based or considering this line of research by Francesca Toni on argumentation-based recommender systems. And we can also consider interoperability enhancements. For example, now we just provide ordinary JSON import-export without considering anything like the argument interchange format or similar. Of course, what also would be interesting is to look at what kind of capabilities Tweety provides beyond abstract argumentation and how to integrate them. into our system, or even if there are some things in our system that we could merge into treaty because they're generically useful. For example, checks whether one argumentation framework is a certain type of expansion of another argumentation framework, and so on. And of course, an evaluation would be interesting. So to check what it costs to ensure consistency. And there we have theoretical results that show that given the property, the exact property you want to enforce, there are semantics that allow you to always pick an extension that ensures consistency, while other semantics might require, let's say, more brutal manipulation. And of course, if you pick the right semantics, this means that you that it takes much less effort, computational effort, to be consistent. That's it. Our code is on GitHub. There you also find a more detailed tutorial and like an engineering-oriented tutorial. And if you're interested, you can open issues there and so on. Thank you very much.